Example number 2. Can you show that the following basically recurring decimals are rational? So let's quickly look at the scaffolding. We have got 9 blocks. On the ninth, after the 9th block, I'm drawing a line. 9 blocks, draw a line. And then if this is block number 1, I'm going 6 down and I'm drawing a line down there. So I've got 2 questions, but I've got 3 blocks. So this one I'm going to use for things that you do in your head or the steps that you're taking, but in actuality we don't write that down. Our answers are going to be in these 2 because this example only has 2 questions. Okay, so first thing that I want you to do, we know that 0, 1 recurring actually means 0, 1, 1, 1, 1, 1 ellipsis, right? So this is 1 repeating until infinity. I want you to say, let x equal that. Let x equal 0, 1 recurring to infinity. Our next step is you are going to tell me, let 10x equal. Now, what does this mean? It means you are going to say 10 multiplied by x. And we just said that x is 0, 1 recurring. So you're going to say 10 multiplied by 0, 1, 1, 1, 1, 1 recurring. Now, remember the one thing that I keep repeating in class is use your calculator. Even if it seems silly, it really doesn't matter, okay? So if you have 0, 1, 1, 1, 1, 1, 1, 1 recurring, and you multiply it by 10, what happens is that your decimal number moves 1 to the right because that 10 means 1, that 0 means 1 space, right? So we move 1 to the right. So that means that this is actually the answer of 10 times this is 1, 1, 1, 1, 1, infinity. So that's what we want here, 1, 1, 1, 1, 1 to infinity. Now you are going to subtract. So in your brain, these 2 should actually be the other way around. But what you're going to say is you're going to say 10x minus 1x. That's what we're going to do here. 10x minus 1x. You're going upwards. You're going upwards on paper, but yeah. Okay, so 10x minus 1x. And you know what 10x is, right? 10x is 1, 1, 1, 1 forever. So we're going to say 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 to the end of the screen minus, and we're doing x alone, which is going to be 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That's one too many on the screen. Maybe it's not. And I press equal. My answer is going to be 1. So what happens? All of these 1s cancel out. 1 minus 1 is 0. 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 All the way to infinity. So we get rid of everything after the decimal comma by saying 10x minus 1x gives me only what's in front of. So all this, let's see what we can do to indicate it. Now, on your paper, you don't actually have to mark it, but I just want to show you. This is what we want gone. That's what I want to disappear. So that means that I'm left with 1 minus 0 is 1. And 10x minus 1x is 9x. Does that make sense? Now, I want to prove this is rational, and what I want actually is I want to prove it's a fraction, because a fraction is by default rational, and all decimals that are rational can be written as a fraction. So now I don't have a fraction. I have 9x equals 1. In order to get a fraction, I'm going to say 9 times x, the opposite of multiplication is division. So I'm going to say divide by 9 on both sides. I can write it like this, or I can say divide by 9, divide by 9. So 9 divided by 9 is 1x, which is what I want, is equal to the fraction 1 over 9, and that is my goal. I wanted to prove that. Okay, so what did we do? We said, let x be the number written out. Let 10x be 10 times that number written out. Subtract the big one from the small on the left-hand side. 10x minus 1x gives me 9x. Subtract the big from the small on the right-hand side in order to get rid of all the numbers behind the decimal. Divide by whatever is in front of x. On both sides, x equals a fraction. Let's repeat it on the right-hand side. So on the right-hand side, we have 1,75. Step 1, let x be the question that they give us. If you want to, you can actually write step 1 on the second line. You can say, okay, x equals 1,757575 ellipsis. I'm thinking that makes sense to you, right? So x equals this, but instead of the dots, we're going to write it out with an ellipsis. Now, step 2 says 10x, but what's different between 0,1 and 1,75? I'm not looking at this, I'm looking at the fact that there are 2 digits here. I decided on 10x because I had to move 1 decimal place to the end of the recurring. Over here, I have to move 2 decimal places, so I am going to have 2 zeros on my x. Please pay attention. Okay, so if I need 2 zeros, then is 100x going to work? Yes and no, because what we're going to do is we are going to say, okay, let's say 100x equals, and I'm moving this 2 zeros 2 places to the right. So that's going to be 175, 757575 dot dot dot. Are you happy with that? So 100x is 175,757575 when 1x equals 1,757575. Now I am going to divide. Oh, sorry, first subtract. So what are we subtracting? We are going to say 100x minus 1x, and that gives us 99x. And that 99x is going to be equal to, again, notice, 7 minus 7 is 0. 5 minus 5 is 0. 7 minus 7 is 0. 5 minus 5 is 0. 7 minus 7 is 0. 5 minus 5 is 0. This must be exactly the same. That will disappear, which is what I want. I want that gone. So when I subtract, right? So what do I end up with? I end up with 175 minus 1 is 174. 99x is equal to that. Now I wrote in pink instead of blue. Okay, so what's my next step? My next step is going to be to get rid of this 99. This is multiplication. So the opposite of multiplication is division. Divide by 99. 99 over 99 is 1. That's what I want. What I do on the left-hand side, I do on the right-hand side. Divide by 99. So that means my answer is x is equal to 174 over 99. And that is how you show a recurring decimal is a rational number. You convert it to a fraction. Let the question be x, and then choose how many zeros based on how many numbers you have to move, and that is determined by the recurring numbers. Go to the end of the recurring numbers. 2 hops, 2 zeros. 1 hop, 1 zero. 3 hops, 3 zeros. Move it up. Subtract big minus small, divide by whatever is in front of x to get 1x equals a fraction.